Hello everybody, my name is Peter Klapper from the School of Biosciences at the University of Kent in Canterbury, and in this video clip I want to discuss the concept of sampling error and null hypothesis, or in general hypothesis testing. So what does this actually mean? Well, let's assume we have a large population like this, so that is our population. Let's say this is the number of, this is all the students at the University of Kent, so it's roughly 20,000 students. And we want to know what is the average height of all the students in the university. And of course, it would be fairly impractical to measure everybody, so we just simply take a small sample. So this is a sample here. And our concept is that from this sample, we hopefully then can make an inference about the height of all the students of the population. So this is a sample here. Now let's say in my sample, I measure here that the mean height of the students in this sample, let's say I take 4 students, I measure 4 students, so my sample size is 4. So let's say this mean, the average height of these 4 students is 178 centimeters. And I would now be able to calculate and estimate how big my average height of all the students is. Now, of course, I can take another sample. I can take another sample, say another 4 students here, and I measure the height of these 4 students, and the average is, say, 181 centimeters. Or I can take another sample here. So here, this is a sample. Again, let's say n equals 4, and my average height here would be, say, 175 centimeters. So with all these samples, I get different averages. Now, this makes it now quite interesting, because I can say that all these different averages that I have for the sample 1, for sample 2, for sample 3, and whatever sample I choose, they all represent, up to a certain point, represent the population mean. Population mean. And that's the abbreviation for mean. Now, very clearly, these different sample means, they are not all the same. And that's very important to remember. They can be quite different, but they are still representing the same population. So, in a way, we can say we have different sample means, but these sample means are only different. The sample means are only different because I use different samples of the same population. So each one of these sample means is a representation of the population, but the sample means are different. And this is called the sampling error. Sampling error. Now, it is not a technical error as such. It is just simply a difference in the sample means. So we can say it's a difference in sample means caused by the sampling method, Very clearly, I can now compare two samples with each other and ask whether these two samples are different only because of the sampling error. What does that mean? Well, let's say, again, I've got my population. I take a sample here, say x minus x bar 1 and x bar 2, and obviously these two sample means will almost certainly be different. But is this different only caused by the sampling error? So, in other words, I can say there is no difference between the means of these two samples other than caused by my sampling error. This is actually what we call the null hypothesis. Null hypothesis. And very often we abbreviate that as H subscript 0. H subscript 0 means there is no difference between the two sample means other than due to sampling error. On the other hand, the null hypothesis always says that there is no difference other than caused by the sampling error. The alternative hypothesis says there is a difference between the two sample means which is caused by the sampling error and an additional factor. I hope this makes sense, and thank you for watching. Formulate an alternative hypothesis. So I can write alternative hypothesis. That's usually called H1. And I can say in this case, alternative hypothesis, there is indeed a difference between the two sample means. And this is caused by the sampling error. We will never be able to eliminate the sampling error, but there's in addition to that another factor. An additional factor comes into play here. What could this additional factor be? Well, this additional factor could be that our two samples here are actually from two different populations. So this would be population 2, this would be population 1. And if this is the case, then most likely our two sample means would be different. So the null hypothesis always